Change FTX's mind for $1.5 million, get a new perspective on interpretability, engage with the speed prior, and join our hackathon. Today is September the 30th. My name is Esben, and you're watching the Safe AI Progress Report. The FTX Future Fund announces a $1.5 million prize to change their mind about the risks of artificial intelligence. Until now, they've donated upwards of $31 million to this cause, and changing their mind might completely change where this money goes. If you change their probability estimates drastically for how dangerous AGI is and when it will arrive, you'll be eligible for the prize. An early submission is this post advocating that scary AI will arrive soon. It covers how we expect early general intelligence to be much more scary than later AI, since we won't have nearly as much time to prepare, and there are just several variables in understanding how early the onset of scary AI is that we cannot be sure about. A very good submission. Conjecture releases great research in interpretability, the polytopes lens on feature space. They argue that we should not understand features as directions, but as geometric structures in feature space, due to the nonlinear activation functions and polysemanticity. Despite the fact that one neuron can encode multiple features, the polysemanticity, they can identify monosemantic polytopes, which just means that if we don't study features as directions, but as geometric shapes, we can identify where input types are interpreted better. This challenges the circuit interpretability we have talked about before with an experiment where they scale activations and see a difference in what the network understands. This implies that we cannot use linear directions as features, but should use these polytopes. Anthropic works a lot in circuit interpretability, and they have simultaneously published some amazing work on understanding this feature superposition, which is just the understanding that features is spread across many neurons. For example, one neuron responding to both cars and dogs. This enables the network to understand more things, but simultaneously it makes it harder for us to understand it, unfortunately. Their work shows an array of interesting experiments studying when feature superposition occurs, such as in this figure where the yellow indicates higher superpositioning, and feature geometry graphs that show how superpositions are possible through encoding information in the most distinct directions as possible. There are more experiments, and I recommend you read the paper if you want to know more. Perez and Mackenzie released the winners of the first round of the Inverse Scaling Prize. This challenge attempts to find tasks where larger language models perform worse than smaller models, which is exceedingly important to know where much larger models out in the future might hit roadblocks in their compatibility with human values. The winners show that larger models are worse at understanding negation, they more often repeat what they have seen in their training set, they are worse at redefining definitions of words, and they are also worse at understanding future risky behavior. Evan Hubinger has released his summer experiments that build upon his work on so-called speed priors. Basically, we expect future dangerous AI to deceive humans, and so we need a way to punish algorithms that deceive. One way is to find a regularizer, or a penalty to networks, that is biased towards non-deceptive models. The speed prior attempts to do this by selecting for the model that is fastest as a task, since we assume that deception requires extra steps and more time compared to just doing the task at hand. His new work presents attempts to use speed priors on multiple levels, solving inner misalignment as well. As we explained in the second Safe AI Progress Report, inner misalignment is when a model appears to do the right thing, but is deceptive or has its own goals underneath the first layer. To alleviate this problem, we want the speed prior to work on both levels. Most of the approaches he presents do not have a lot of promise, but they might warrant future research. Leo Gao describes how reinforcement learning policies cannot care about the reward in an embedded setting, but that they are still capable of wireheading. This extends to the fact that there is no special mechanism in humans that makes us care about things in the world. Leo's writing is in a response to a text from Alex Turner with the weaker claim that reinforcement learning agents probably won't optimize for reward. In other news, Holden Karnofsky analyzes how the deployment of AI is incredibly important and questions the view among theorists that we just need to solve the technical alignment problems and we don't need to worry that much about how the world deploys these models. Akash and Thomas describe new alignment researchers' 7 main mistakes and how they often end up stuck in upskilling and don't question authority figures. But some places where new researchers might arise with better fundamentals is the language model hackathon that we are running over the weekend starting today. You're very welcome to join the hackathon in the middle of the weekend, and you can win up to $1,000. Join us to figure out if we can get novel research results in just one weekend. Another event happening is the AI Safety Conference by Alter in Israel to put more focus on AI safety in the country. Our very own Faisal Bades will be speaking at this event. And as always, if you want to learn more, go to apartresearch.com, and if you want to find projects to work on, go to aisafetyideas.com. This has been the Safe AI Progress Report, and we look forward to seeing you next Friday. Thank you for watching.